Hello, welcome back. In this segment, I will discuss how to make system calls from assembly code. For example, if you want to call exit is a system call function, is part of the Linux kernel. So how can we activate that from our assembly code? Let's take this exit.s file. Okay, I have all these comments here to notify you that the system call number is stored in EAX and the argument to exit function is stored into the EBX. Okay, so the general structure is as follows. Here is your text region, and you're defining a function called _start. And as I said earlier, EAX holds the system call number. So 1 stands for exit. So 1 is moved to EAX, and we are going to do EBX with 0 because we are trying to call exit with status 0. Okay. So suppose you would like to have exit with status 1 or 2, you just put here 2, right? Compile, and if you now type echo with the $? You get 2. Okay. So what's happening here is you need to know which value to put into the EAX. Of course, the argument first argument goes to EBX, second to ECX, third to EDX, and so on. And then interrupt is the signal you're sending to wake up the kernel to run the exit command. Okay. All right. So how do I know which number to push for a particular system call? There is a system call table in Linux, and I will show you one such table. There is a publicly available system call table for 32-bit Linux, right? For example, we just did exit, system call exit, EAX value is 1, and EBX value, I set it to 2 for exit of 2. Let me show you something that will involve ECX, EDX. For example, let's take, let's say system write, where I will show you hello world, yeah? How to make a hello world call from assembly using the syswrite function, or we will make a system call to write. Okay, let's do that. I'll share that with you in a moment. Okay, so we are done with exit of S file, where we did exit of 2 in this case. And now let me show you how to make, say, for example, syswrite call, right? Okay, so to write, we need to use the EAX register with the value 4 as shown on the table. 4 means write. And to write it to the standard output, I'm going to put 1 to the EBX register. That's the first argument. And then my hello world string, which is the third argument, pointer to the hello world string, right? That's what's happening here. Hello world string is a label. So when you refer a label, you're essentially referring the address, which is pointing to H. Okay. And the fourth argument, rather the third argument, is the length of the string. If you count this, including the new line, you'll have 12 into the EDX register. Okay. And then the rest is simple. Call the interrupt, right? You put int 0x80, and that will transfer the control from user space to the kernel space, execute this code, and control will come back, and then we will exit the code with the exit part that I already talked about. In this case, exit with status 0. Okay, so let's compile this and run it. as-o hello world dot o hello world dot. Okay, we got hello world. The exit status will be 0 because we are doing exit of 0 at the end. Okay, let me summarize what we went through. We need to identify the value that we need to put into the EAX, okay? And then the arguments to that particular function. EBX is the first argument, ECX second argument, EDX is third argument, and then interrupt to call the system call. Okay, you need to look into the documentation to figure out, suppose you would like to call write. Okay, write means EAX has to be 4. Suppose you want to do read, it means EAX has to be 3, and so on. Okay, and once you have this table, it's easy. All you have to do is making sure the parameters are properly initialized, and then you're ready to go. With an interrupt 80, you're jumping into the system call and execute the call. That's basically it. Thank you very much.